Hi, welcome to my video on the slope of a parabola. Let's look at the parabola f of x equals x minus 2 all squared minus 3. The vertex of this parabola is the opposite of negative 2 is 2 and negative 3. So the vertex is 2, negative 3 right here. And because this is positive, the vertex is opening upward. So I'm just going to draw it going upward, and I'm not really concerned where it's cutting through the x-axis right now. So I'm just drawing it like this just to, so the vertex is 2, negative 3. So as a result, we have a parabola. At the vertex, the slope of the tangent is 0. So this tangent is y equals negative 3. So the slope of this tangent is 0. And that's the slope of the tangent, which is f prime, is equal to 0 when x is equal to 2. Now, if we take the derivative and say the derivative is equal to 0 at x equals 2, and the derivative is the slope of the tangent when the derivative is greater than 0, that means the derivative is positive. The graph is increasing, as on this side, and that happens at x is greater than 2. So when x is greater than 2, the slope of this part of the parabola is positive, because if you draw a secant or draw a tangent here, it'll be positive slope. And if you have the derivative less than 0, which means the slope of the tangent is negative, that's the tangent is negative on this side because it's going up to the left. So that's when x is less than 2. And that works for this one because it's, again, because it's opening upward, it's positive on this side and it's negative on this side. Let's look at another parabola which is negative, which is opening downward. So the vertex of this parabola, x is negative 2, y is 0. So x is negative 2 right here, y is 0. And because this is negative, the parabola is opening downward. And I'm really not concerned exactly what point is passing through, it's just that it's opening downward from this point of negative 2, 0. And the derivative is the slope of the tangent. So the derivative f prime x is equal to 0 when x is negative 2. So at the x-coordinate of the vertex, the tangent, slope of the tangent will be 0. Now, if we take the derivative and make it greater than 0, so the derivative is greater than 0 means the derivative is positive. That's positive on this side. So that's when x is less than negative 2. So at negative 2, the slope of the tangent is 0. To the left, the slope of the tangent is positive, greater than 0. And the slope f prime x is less than 0. And less than 0 is negative, and is negative here. So that's on the right side. So that's when x is greater than negative 2. So hopefully you can understand from this graph what I'm getting at, where the slope of the tangent is 0, the slope of the tangent is greater than 0, which means it's positive, is increasing. The slope of the tangent is negative, which means it's negative. Slope is negative, is decreasing. Okay, knowing that, let's work out some of these questions. I have a parabola drawn. State the values of x on this parabola. The vertex of this parabola is 1, 2. X is 1, y is 2. So the derivative is greater than 0. The derivative is positive on this side. So if you draw a tangent like this, you'll see that the tangent is positive. And so it's when x is less than 1. And the slope of the tangent is 0, as at the vertex when x is equal to 1. And the slope of the tangent is less than 0, and it's in relation to 1, but it's greater than. So less than, slope of the tangent is negative here, when x is greater than 1. Let's look at another one. And again, find the values of x when the derivative is positive, 0, and negative. So this is the vertex right here, where x is 2, y is negative 1. So the derivative is equal to 0 when x is 2. So that means the other ones are going to be in terms of the 2. So the derivative is greater than 0. The derivative is positive on this side here. So that's when x is greater than 2. And the derivative is negative on this side when x is less than 2. And we have another one to do. State the values of x. Oh, let's put a 3 here. I got 3 left out. State the values of x when the slope of f of x is increasing. So the slope of f of x is increasing is when its derivative is greater than 0. So that's the same as saying the derivative is increasing is greater than 0. And decreasing is when the derivative is less than 0. And the slope of f is 0 when f prime x is equal to 0. So the vertex is negative 1, 0. So these are all in terms of x, negative 1. So it's negative 1, negative 1, negative 1. So it's equal to 0 when x is equal to negative 1. It's increasing. Increasing is on this side here because it's positive here. So when x is greater than negative 1. And the tangent is negative here when x is less than negative 1. And we have another one to do with increasing and decreasing. Again, increasing is when f prime x is greater than 0. Equal to 0 is when f prime x is equal to 0. And decreasing is when f prime x is less than 0. So the vertex here is negative 2, x is negative 2, y is 3. So it's in relation to the negative 2. So I'll put the negative 2 here 3 times. So it's equal to 0 when it's equal to negative 2. And it's increasing, increasing. That's decreasing here, so it's increasing on this interval. So that's when x is less than negative 2. And right here is decreasing. Decreasing, the slope of the tangent is negative, is when x is on this side greater than negative 2. So we got the increasing is when the derivative is greater than 0, decreasing when the derivative is less than 0. And the derivative is equal to 0 means the slope of the tangent is 0. So let's look at just a couple more questions. Sketch each parabola if f prime x is greater than 0 when x is greater than 1, f prime x is less than 0 when x is less than 1, and f of 1 equals negative 2. So the f of 1 equals negative 2. So that means we have a point 1, negative 2. So 1, negative 2 is right here. So notice greater than and less than. So it's the 1 is the value. So it's positive when x is greater, derivative is greater than 0 when x is greater than 1. So it's positive on this side. So that means opening up this way. And it's the derivative is less than 0 when x is less than 1. So that's to the left. So there's a sketch. Again, it's a sketch. It's not a true, it's not a, because it's not accurate. The only thing is accurate is the vertex is 1, negative 2. That's the vertex. And it's positive on this side because it's greater is positive on the right side. And it's the derivative is negative on to the left of 1, less than. B, we have a vertex of negative 2, 3. Negative 2, 3 is right here. That's the vertex. And when the derivative is greater than 0, the derivative is positive when x is less than negative 2. So that means positive. Positive is like this. So think about it as drawing a tangent. That tangent is positive. and its derivative is less than 0, negative, when x is greater than 2, greater than negative 2. So there's the parabola. It's positive on this side, negative on this side. So it's positive when x is less than negative 2, and the slope of the tangent is negative when it's greater than negative 2. So there's the parabola. Again, it's just a sketch. And it brings us to the end of the video. And if you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content I have on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.